Okay, so we are doing our exponential and logarithmic graph notes, and we're going to start by making a table of values for the parent function. So did you do that yet? Did you do 2 squared? What does that give you? 4, good. 2 to the 1? 2 to the 0? 1, good. 2 to the 0 is 1. 2 to the negative 1, what does that give you? 1/2 reciprocal. And 2 to the negative 2? That's good, Ellie. 1/4. Okay. So let's put those numbers on your graph. -2, 1/4. Okay, so that's what our graph looks like. What is missing on my graph? What should I have on there? An asymptote, that's right. Do you guys remember what kind of asymptote you have on an exponential graph? No? Any guesses? Okay, those are the 2 choices, vertical and horizontal, very good. And this one, it seems like it's kind of leveling out at y equals 0. And that's where it has an asymptote, at y equals 0. So it has a horizontal asymptote. All right, so that's the parent function for everything that we're going to graph on this page. Let's go through the transformations and see if we can figure out what they're going to do. So based on your warm-up transforming parabolas, what do you think the plus k will do to the graph? Move it up and down, right? Okay. So what is that called? That's vertical, right? Vertical shift. Okay. How about the h that's inside the function? What's that going to do? Say it again. Horizontal, yeah. Horizontal shift. Okay, the A.
Stretch.
The stretch, yeah. So it would be a stretch or a compression, depending on what number it is. And it's going to happen vertically. You could have a horizontal stretch or compression, but we don't really have any examples of that, so it's not in our formula. So this is going to be vertical stretch or compression. If the A is negative, reflected, and it's going to reflect vertically, just like with this A, reflect vertically. And if the X is negative, what's that going to do?
Is it reflect horizontally?
Very good, Kieran. Okay, so let's do one together, and then I'll give you a minute to see if you can figure out the rest of them, okay? The first one is 2 to the x plus 2. So what does that plus 2 do? Jack says move to the left. What do you think? Is he right that it's horizontal? Because it's up here, plus 2, so that's up here. So he's right that it's horizontal, and is he right that because it's inside the function, it's going to happen inversely and it's going to move to the left? Yes. Okay. So we're going to move all of our points left 2. And I actually, because these fractions are so small and difficult to graph, I don't usually graph 5 points, I graph 3. So I usually graph the middle 3. So I'm going to take the middle 3 points and I'm going to move them left 2. I'm going to start by taking this one that's at 0, 1, and I'm going to move that left 2. And then I'll take the point that's at -1, 1/2, and I'll move that left 2. And And the point that's at 1, 2, move that one left 2. So it's the same shape. We like literally slid it over. What happened to the asymptote? Oh, sorry guys. What happened to the asymptote? Yes. Nothing. Very good. If you take your horizontal asymptote and you shift it left, I mean, the line goes infinitely in both directions, so that doesn't really do anything to your asymptote. It's in the same place. So our asymptote is still at y equals 0. What's the domain of this function? Starts over here at what? Negative infinity, and it continues going until positive infinity. Thank you. Oops, I put it for the range, and that's not the range, is it? All right, the range does not start at negative infinity. It starts right after what number? Say it again. 0, very good. It starts right after 0. It can't hit 0 because of the asymptote there, but it starts right after 0. So what we're going to do is we're going to start our range with a parentheses in the 0. That means not including the 0. And then it goes up to what number? Infinity, good. Okay. All right, so I'm going to pause here for a minute and see if you can try the rest of the ones on this page, and I'll come around and help you. Okay, we did this one already. Did we do this one already? No. So this way she shifted which direction? Right 3. So if you're confused about her points, she actually ended up using the last 3 points, 0, 1, 1, 2, and 2, 4. And a lot of people like to use those points instead of using the negative 1, 1/2. That's totally fine. As long as you have 3 points, you're good. Her asymptote stayed in the same place for all of the graphs except for which one? The third one, because in this one, everything shifts up 1. So her asymptote now is at y equals 1. Oh, and that will change your range though, right? Do you mind if I change it on here? What should it be, Tara?
1.
Good. 1 to infinity. Awesome. All right, so everything shifted up here. This one proved to be the trickiest one for people to graph. So when you have a vertical stretch, sometimes you just want to think about it algebraically. All your y values are multiplied by 3. So if Tara was doing the point at 0, 1, you multiply the 1 by 3, so now it's 0, 3. And if she was doing the point at 1, 2, you multiply the 2 by 3, and now you have 1, 6. Okay? So multiply your y values by 3. That will help you plot this one. Over here, you can just pick up your points and reflect them across the x-axis. And here, you can reflect your points across the y-axis, and you should be good. Does anybody have questions on the domain and range or any of the points that are here? Okay, so we're going to turn the page and do a harder question, okay? I will pass you your paper just a second. Okay. Thank you. Okay, so here is the problem that we are trying to graph. Y equals negative 3 times 2 to the x plus 1 plus 5. That's a lot of things to happen at once, right? So we're going to do an algebraic approach. You start by making a table of values for the parent function. The parent function is y equals 2 to the x. And I'm gonna use my points, but if you prefer to use the points that Tara used, that's fine too. My points are negative 1, 0, and 1. Tara liked using 0, 1, and 2. It's up to you which one you use. So 2 to the negative 1 is 1/2. 2 to the 0 is 1, and 2 to the 1 is 2. 2 is not the base of every exponential function. We've been dealing with it a lot today just for simplicity's sake, but your base could be 3 or 5 or 10. It could be e, which is super fun. All right, so this is our parent function. algebraically, what happens is, if you have x plus 1, you know that's really going to go to the left. So algebraically, you are going to subtract 1 from these x's. So you would have, let me see if I have another color to use. Negative 1 minus 1, which is going to give you negative 2. You have 0 minus 1, which gives you negative 1. And you have 1 minus 1, which gives you 0. Okay. So did you see how I took these x values and I moved all my x's left 1 by subtracting 1 from them? All right, and 3 things are happening to your y, which is why it's really difficult to do this without the algebra. Because what you're doing is you're reflecting, you're stretching, and you're shifting all at once. So you take all the things that happen to the y, and those are the things on the outside of the function. This is on the outside, and this is on the outside. Those things are happening to the y, and we're going to change your y values. So it's negative 3 times 1/2 plus 5. I'm taking that 1/2, I'm reflecting it, I'm multiplying it by 3, and I'm adding 5 to it. I'm shifting it up. So this is going to give me negative 1.5. Negative 1.5 plus 5 is what? Close. Negative 1.5 plus 5. Look. How about 3.5?
Oh, sorry.
You think negative 1.5? Because negative 1 plus 5 is 4, and then another negative half is going to be 3.5. Okay, so this is 3.5. All right. Negative 3 times 1 plus 5. That's a little easier. What does that give us? 2. And negative 3 times 2 plus 5 gives us what? Negative 1. Bless you. All right, so these are the points that we're graphing. We're graphing negative 2, 3.5, negative 1, 2, and 0, negative 1. Negative 2, 3.5, negative 1, 2, and 0, negative 1. My horizontal asymptote was also changed, and because the horizontal asymptote is a y equals equation, you can plug it into the same y equals function here. So normally it's y equals 0. If I plug 0 in, I have negative 3 times 0 plus 5, so it shifted where? Y equals 5. Okay, so at y equals 5, we want to draw your horizontal asymptote. And then this is an exponential function that's been flipped upside down. It's going to look like that. All right, should we do another one together? Or you feel ready to do it on your own? Another one together? Okay, which one do you want to do, 9, 10, or 11? That was not a choice. 9? Okay. So we'll do 9. We have the same base, so we're still dealing with the same parent function, y equals 2 to the x. So it's still this table of values that we're transforming. Okay, it says x plus 2, but we know that happens inversely, so what happens to my x? Instead of plus 2, which way should it go? Minus 2. So remember that the x's happen inversely, so x minus 2. And then what happens to the y? Okay, so y minus 4. What's going to happen to my asymptote? Is my asymptote going to stay where it is, go up, or go down? It's going to go down, right. If I put 0 into my y function, 0 minus 4 is negative 4. So my asymptote is at y equals negative 4. So I'm going to graph that first. That will help me keep all my points in place. Okay. Now if you can do this math in your head, you don't have to write it all out in the table. You can write just the answers in the table, but I'm trying to show you where the answers are coming from. So it's negative 1 minus 2, 0 minus 2, and 1 minus 2. I'm putting the x's for my parent function in here, and I get negative 3, negative 2, negative 1. And then y minus 4, so that's going to be 1/2 minus 4. 1 minus 4. 2 minus 4. Negative 3.5, negative 3, and negative 2. So what we found here are the points that we're going to graph on our transformation. Negative 3, negative 3.5. Negative 2, negative 3, and negative 1, negative 2. All right, what's the domain going to be? That's right, EJ. Negative infinity to positive infinity for any exponential function. My range starts right after what number? It starts right after the negative 4. So I'm going to do parentheses negative 4 to not include it, and it goes up to what? Infinity. Good. All right, so I'm going to pause here and give you a chance to try the next one. In the next one, what's happening to the x? Well, I see the reflection, but it's on the outside, so that's going to happen to the y. So is there anything happening to the x? No. So the x will stay the same from your parent function, and two things will happen to your y. The one thing that Jack pointed out, the reflection, and also the plus 3. Okay? So when you make your table of values here for the transformation, your x stays the same, and your y will be negative y plus 3. If it helps you, you can write out the parent function again, or you can just refer back to this parent function here. Okay? So I'm going to pause for a minute and see if you can try that one and the next one. Okay, so in this problem, nothing happened to the x, and your y was negative y plus 3. So I'm taking from the parent function, negative 1/2 plus 3 is 2.5. Negative 1 plus 3 is 2. And negative 2 plus 3 is 1. And my asymptote, if I put y equals 0, which is what the asymptote from the parent function, into this equation, I have 0 plus 3. So my asymptote is going to be at y equals 3. So I'm going to graph that. And graph my points. Negative 1, 2.5. 0, 2. Oh, did I not go far enough up? Yeah, this is supposed to be here, and this is supposed to be here, right? And then 1, 1. Yeah, I got off a little bit, sorry. So it's like there. There we go. So how come the graph is below the asymptote this time? Because of the negative, right? That reflected it. So this time, my domain is the same, but my range starts where? Negative infinity up to what? 3. Okay, questions on that one before we do the last one? So for the last one, what happens to the x?
Minus 1.
So it says minus 1, and when we do it inversely, what do we do? Plus 1, good. And then what happens to the y? It's half of y. So, you know I love the points -1, 0, and 1, but because our y's are going to be cut in half, we might not see very much here. I'm going to put in that next point too, just so I can see more. If you didn't do it, that's okay, as long as you're getting the right shape, okay? Alright, so then, those are not my final ones though, right? I need to add 1 to them. So this becomes, when I add 1 to it, it becomes 0. This becomes 1. This becomes 2. And this becomes 3. Those were for my parent. Sorry. Okay, so guys, -1 plus 1, right? I see I confused you, I'm sorry. -1 plus 1 gives me 0. 0 plus 1 gives me 1. 1 plus 1 gives me 2. And then the last one for my parent function would be 2 to the 2 is 4. So 2 plus 1 gives you 3. Okay. Half of your y's. Half of a half is what? A fourth. Good. 1/2 times 1/2 is 1/4. 1/2 times 1 is a half. Good. 1/2 times 2? It's 1. And 1/2 times 4 is 2. So guys, I just added in that last point because my other points were so small that they were going to just get crowded together. I wouldn't be able to see the shape that well. So this is what I'm graphing. 0, 1/4, 1, 1/2, 2, 1, and 3, 2. And what happened to my asymptote? Where is my asymptote going to be?
0.
Still at 0. Good. Because if I do 1/2 times 0, I still get 0. So my asymptote is at y equals 0. All right, now I'm going to plot the points. Same domain, and where does my range start? Where does the range start? 0. 0 to infinity. Thank you. Okay. So I think that procedure, it's a little hard to get used to, but once you get used to it, it works for graphing any transformation of an exponential, so that should be helpful. Now we're going to graph logarithms. Do you remember graphing logarithms in Algebra 2? Instead of having a horizontal asymptote, what does it have? It has a vertical asymptote. That's good. Okay. And the logarithm is the inverse of the exponential. So the way we're going to graph the first logarithm is by finding the inverse from the table of values. When you do the inverse of a table of values, what do you do with the x and y? You switch them. So the x becomes the y and the y becomes the x. So that's what we're going to do on the next page. Okay. So since y equals log base 2x is the same as x equals 2 to the y, the inverse of the logarithm is the exponential. We can use that to make our graph. So we are going to make 3 tables of values. The first one is for y equals 2 to the x. The second one is for its inverse, which is y equals log base 2x. And the third one is for the, we don't need a third one because there's no transformation. We would do a third one for a transformation though. All right, so y equals 2 to the x. Our points were negative 1, 0, 1, which gave us 1/2, 1, and 2. For the inverse, you switch the x and the y. So now the x's are 1/2, 1, and 2. And the y's are negative 1, 0, and 1. You also switch x and y for your asymptote. So if your asymptote used to be y equals 0, now it's what? X equals 0. Good. Okay. So let's graph x equals 0. And graph your 3 points. So you're getting infinitely close to your asymptote here. And this one's going to go this way. Okay, questions on graphing the first logarithm? All right, this table is outlining all the different transformations you could have. You should not be surprised by them because we've transformed a parabola and an exponential, and the logarithm works exactly the same way. So that if you see a +1 after the log, you're going to realize that shifts it which direction? Up 1, good. So this is up 1. What's this one going to shift? Left 3. Yes, good. The negative on the outside of the function is going to reflect which way? Sorry. It's going to reflect vertically. And the negative on the inside of the function is going to do what? Reflect horizontally. So I'll do one of these with you, but I think you guys are very capable of finishing these. Okay. So up 1, I'm going to take my points from my parent function here, and I'm going to shift each point up 1. So this point was at 1/2, negative 1. So it's going to go to 1/2, 0. And then the next one was at 1, 0, so that's going to go to 2, 0. No, it's going to go to 1, 1. And this one was at 2, 1, so it goes to 2, 2. What happened to my asymptote? Stay the same, yeah. When I shift that asymptote up 1, it looks exactly the same. Let's see. So this moved up to 2, 2. This moved up to 1, 1. And this is 1/2, 0. Because the negative 1 moved up to 0. All right. Your domain starts right after what number? 0. So your domain is 0 to infinity. And your range? Negative, good. Negative to positive infinity. And your asymptote is an x equals what number? 0. All right, so take a minute to try to finish up the rest of the transformations on this page, and then we'll turn the page and do more complicated ones. Okay, so we said that this one is going to move left 3, so you can see that Annabelle moved her asymptote left 3, which affects your domain. And then this one was reflected vertically. So the point that was at 1/2, negative 1 is now at 1/2, positive 1. And the point that was at 2, 1 is now at 2, negative 1. And then this last one was reflected horizontally. So let's see, your point that was at 1/2 -1 is at -1/2 -1. Okay? So make sure you can see your points here. Make sure you've adjusted your domain because it's the left half of the graph instead of the right half of the graph. Do you guys have any questions on this work? All right, so we'll leave it up for one more minute and then we'll go to the back and we will graph logarithms. It is a 3-table process to graph a transformation of a logarithm when it's complicated, but it's worth it because it's very straightforward. Instead of getting confused with, like, what do I do first? Just do the algebra. All right, so now we have a logarithm with more than one transformation on it. You could actually have like 3 or 4 transformations on your logarithm, which would make this method even more helpful. But we're starting off with just a negative and an x plus 3. So we're going to start with the table of values for y equals 2 to the x. And then we're going to switch the x and y's for the log base 2x. And then we're going to do the transformations after that. So this is what we're graphing. Check and make sure your neighbor's on the right page. 2 to the x, we did -1, 0, 1. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And then just like on the last page, we're going to switch the x's and the y's to do the logarithm. So now the x's are 1/2, 1, 2. And the y's are -1, 0, 1. All right, why do I want to subtract 3 from my x's? Okay, so EJ says because the positive is actually going to the left, and that's true. When your transformation is inside the function, in the set of parentheses here, then it happens inversely. So instead of +3, you want -3. And then the negative is on the outside, and that's going to happen to the y. And so that's -y. So these are the points that we're transforming now, here. So 1/2 -3, 1 -3, 2 -3. Okay, so I took the x's from my logarithm and I transformed those, and now I'm going to transform the y's. So the opposite of -1 is +1, opposite of 0 is 0, and the opposite of +1 is -1. My vertical asymptote is also transformed. It used to be x equals 0. So you put that into your x transformation, and you subtract 3, and you get x equals -3. So graph your transformation, and then graph your points. Okay, what questions do you have on that one? So everything we've done so far has been base 2, but some of you guys have looked ahead at the homework, and in the homework, what base are we doing? On the homework, it's base 3, so you're going to have a different parent function, but it's not that bad. It's very much related to what we're doing here. All right, this page, though, is still base 2, so let's do another problem. Let's do number 4. Actually, is there anything that's harder? No. Let's do number 4. So y equals 2 to the x is here. Y equals log base 2x is here. If you don't care to copy the first table over, it is the same one you just did. That's fine. Then you switch your x and y, so this is 1/2, 1 and 2, and this is -1, 0, 0, and 1. And now the transformations. What happens to the x? It's -1. So this is going to be x minus 1. What happens to the y? 1/2, good. So 1/2 y. Alright, so these are the numbers I'm transforming. 1/2 minus 1 is -1/2. 1 minus 1 is 0. And 2 minus 1 is 1. And half of my y is half of -1, half of 0, and half of 1. Where will my vertical asymptote be? Instead of x equals 0, it's x equals where? You put 0 in here. So 0 minus 1 gives us x equals -1. So put -1 on your graph. And graph your points. -1/2, -1/2 is like in the middle of the box. 0, 0, and 1, 1/2. They're very close together, so you could have added another point there if you wanted. Your domain starts at after -1, and your range is all real numbers. Alright, so I'm going to give you a minute, and I would like you to try to accomplish at least number 7, and if you're already done with number 7, also number 8. Alright, so for 7, I skipped right to the log because I already had y equals 2 to the x over here. And now I'm going to subtract 1 from my x's. And I'm going to subtract 2 from my y's. And for the asymptote, that's a vertical asymptote normally at x equals 0. So if I subtract 1 from that, I get x equals -1. So I'm going to graph the asymptote and then the points. -1/2, -3, 0, -2, and 1, -1. So your domain starts after -1, and your range is all real numbers. Alright, if you're trying to get the last one and you don't have it yet, I will put the PDF on Blackboard for you.